Hi, in this video, we're going to look at two of the theorems that you're going to need to know for circle geometry. Now, to begin with, we've got a circle shown over here. It's centered at A, and we've got some lines drawn in it. We've got a line that goes from A to B, and we've got a line that goes from A to C, or otherwise known as radii, and that creates this angle in the middle over here, BAC. I'm looking at this reflex angle. Sorry, obtuse angle rather than the reflex one. I'm looking at the one over here in the middle. And then we've got another point that's over here, that's point D on the circumference of the circle, and that's been joined to B, and from B to D, and from C to D. And that's now created a second angle, and I'm going to call this angle the angle on the circumference. Now you'll notice that both of these angles, both the angle over here at D and the angle down here at A, they're both drawn from this arc, or from these 2 points, B and C. Now, if I go and take the point D and move it around, we'll see that neither this angle down here doesn't change. We want to look and see what's happening with this angle at the top over here, and also to see whether there's any relationship between this angle and that angle down there. Now, in order to do this, I'm going to get the measuring tool out. And so to begin with, I'm going to get the size of the angle at D, and it's measured to be 59.7 degrees. And then I'm also going to get the angle over here at A, and that gets measured at 119 degrees. Now, if I go back and move this point D around, you'll see that no matter where I put it on this arc, this major arc, big arc BC, the angle always seems to stay the same. And the reason for that, fairly obviously, is that the base of the thing, the points where the angle is drawn from, B and C, they stay fixed. However, if I go and change one of these points, say I go and move this down here, you will see that the angle has changed. And you'll see that both the angle at the top and the angle down the bottom have changed as well. I'm trying to move it very carefully so I can get a nice whole number up top there, which I don't seem to be able to do. Let's just see if there we go. Now, if we take a look at this, we've changed the point C, and we've created an angle over here in the middle that's 104 degrees, and an angle up the top over here that's 52 degrees. Now, hopefully you can see that the angle, that's the red angle, the angle at 52, is half the size of this angle down here in the middle, which is at 104. If I go and change my point D, notice the angle stays at 52 because I haven't moved my base points over here, B and C. And we got this relationship that exists between the two. The angle at the center is twice the size of the angle at the circumference. And this is an important geometric fact. You can go ahead and prove it. If you wanted to find out how to go and prove it, you just need to get in contact with me, and I can show you the proof for this. But you don't need to know the proof for it. You just need to know that when you have two angles drawn from the same arc, chord, this arc BC, one of the angles being drawn at the middle of the circle, on the center point, and the other one being drawn in the circumference of the circle. When you have those two angles drawn, the relationship between the two of them is that the one on the circumference is going to be half the size of the one on the center. Notice I move this up here, and let's just move this on a little bit. There we get 130 degrees, there's 65 degrees. Yeah, that's half. And no matter where I put it on that circumference, we're going to get this same feature existing. I can take this up further. There we got 160. Yeah, the angle at the other side is 80. That's all good. I can move this point down over here. Now, this works provided that this angle D over here is in the other segment to the one that this angle down here is. If I go and move the point D down here, it doesn't hold. I no longer get an internal angle, I get an exterior angle, and that doesn't hold. So as long as we're in this major arc BC, the relationship between the angle at the center and the angle at the circumference is always going to be this this relationship of being double the other angle. So there's the first of these angle facts that we've got, and the angle fact says this: the angle at the center is double the angle at the circumference. Now you might look at this diagram and say, well, hang on, these two numbers aren't, this isn't double that. The reason for that is that the package has been rounded, and we're only working to a certain number of to one decimal place. So there's rounding happening in the background over here. So there we have the first thing. The angle at the center is twice the size of the angle at the circumference. Now the second angle fact that we're going to look at is what happens if I've got another angle on the circumference of the circle that's drawn from the same arc BC, same arc that I drew the angle D from. Now we've got the angle D, we've got its size over here, and if we take a look at it, it looks roughly the same. If I go and put a measure onto it, I can see that it is actually the same. And if I go and move this point around, no matter where I put that point on the circumference of the circle, the fact is that this angle over here, the angle E that's drawn from this arc BC, that angle is the same size as this one that we've got over here. And it shouldn't be too surprising if we think about it, because we've got the angle at the center, and both of these angles over here, D and E, are both drawn from the same arc as that angle at the center. The angle at the center hasn't changed, so the angle on the circumference will be half of whatever that angle was at the center. So we can see that we have a relationship that exists here between the two. And that relationship looks something like this. If two angles on the circumference of the circle are drawn from the same arc, okay, we're talking about the arc BC, then they will be the same size. So there are our two, the first two of the circle geometry theorems, or circle geometry angle facts that you need to know. Hopefully this makes sense to you. You need to take notes of these two particular type of angle facts. The first one said that the angle at the center, the blue angle over here, is twice the size of the angle on the circumference, the angle at D, provided that both of those angles are drawn from the same arc, this arc BC. Now, this one, if we just hide the point E over here and these two intervals, this one looks like, I think it looks like an arrowhead. So if you think of this arrowhead type of shape, that might help you see the relationship between the two. When you've got a little arrowhead like this, then the angle on the outside is going to be half the size of the angle on the inside. If we look at the second one, we've got like a little bow tie effect. And that's going to be our second angle fact. If you have two angles on the circumference of the circle drawn from the same arc, then both of those angles are going to be the same size. I hope this makes sense to you. You now need to go and practice these skills on some geometry questions. See you later. Goodbye.